Hello everyone, and welcome back to the course Python for data science. So, last class we talked about functions. We talked about how to define a function, how we can return a value from a function, and we also talked about lambda expressions and some special functions that we will need for data science, such as map and filter. At the end of the lecture, I think I shared some practice exercises with you. So we'll first take a look at those practice exercises and solve all the questions. Then we'll move on to where we left off Numpy last time. So we'll start with Numpy operations, and then we'll move on to the next module, which is on pandas. So yeah. So the first question that was asked was write a code that prints out the grades of given student based on the marks that they have achieved. So we have a dictionary containing names of students and the marks that they have achieved. And we have this grading rubric. So basically, if they scored from 80 to 100, we give them a grade of A. If it's greater than 70, we greater than equal to 70, we give the grade B, and so on till F. So what we need to do here is, since we have a dictionary, we can iterate over the dictionary using a for loop. So here what I'm doing is basically for name comma marks in marks dict dot items. So this function basically gives us all the key value pairs that are there in a dictionary, and the keys are assigned to the variable name and the values are assigned to the variable marks. So in the first step, the value of the variable name will be Sana and the marks will be 89. In the next step, it will be Abir and 55, and so on till we get Manoj and 65. In each of the iteration of the loop, now what we need to do, we need to put a if statement, and we need to check if like the marks fall in the certain ranges, then return a grade. So basically, first what we have done here is if marks is greater than equal to 80. So if the student scored greater than 80, then we print their name and comma, we print a beside it. Elif. So basically, this elif condition is executed if the first condition is false. So we know the marks is not greater than equal to 80. Now we just check if the marks is greater than equal to 70. Then we give the grade B. Then we have two more elifs for marks greater than equal to 60, greater than equal to 50. And then at the end, if the mark is less than 50, we print name and then the grade F. So now if we run this block of code, it should print Sana A, which is greater than 80, of course. Abir D, D is from 50 to 59. Rohit A, Ravi 22, which is F, and Manoj 65, which is C, 60 to 69. Right. Then in the second question, uh, we are given the original fruit list and a new fruit list. For fruits in the new fruit list, if the fruit does not exist in the original list, need to add the fruit to the original list and then print the modified list. If the fruit exists, then we just print the fruit already exists in the list. So now we have two lists, but we are iterating over the new fruit list because we are checking items in that. So now what we are doing is for fruit and new fruit. So for each fruit and new fruit, if fruit is in original fruits, so if the fruit is present in original fruits, we print fruit already exists. Otherwise, we just append that to the old fruit list. Okay, we append the fruit to the original fruits list and then print the list. So you can see on the first iteration in new fruits, we have apple. Apple does not exist here. So this if condition fails, we go to the else, then we append apple to the list and then print the list. So now we have the list. On the second iteration, we have pineapple. This is also not in the list. So we append to the list and then print it. So now the list gets appended by apple and pineapple. Third, we have mango. Mango is already present in the list. That's why this if condition evaluates to true. And thus we just print that the fruit already exists in the list. In the next one, we have strawberry. Strawberry is not there in the list, so it's added to the list and printed out. Then we have lemon, which is present in the list, so we just print the fruit already exists in the list. Okay, great. Uh, in the third question, we have print out numbers from 10 to 0 using a for loop and a while loop. So basically, we have to print numbers from 10 to 0 using both for loops and while loops. In the first part here, what we are doing is we are using a for loop. So for I in range 10 to -1 in steps of -1. So each step it will decrease the value of the variable. So it starts at 10, then 9, 8, 7, and it goes on till 0, which is 1 plus this number that we give. Okay. So this should print out 10 to 0. Then we have a while loop. So we initiate it with number is equal to 10, while number is greater than -1. So we are basically checking if number is greater than -1. If it's 10, 9, 8, 7, 0, 6, 5 till 0, it's greater than -1. If it is greater, we print the number and then we subtract 1 from it so that this counter keeps decreasing. Remember that if you forget to add this part in a while loop condition, it will run forever. So now if we execute this, we should have two lines, 10 to 0 and 10 to 0. Okay. In the fourth question, we have print the following pattern to the screen using loops. So basically, this is a multiplication table kind of thing. Okay. It's basically a square table. We are just taking one value and squaring it. So in the first case, we have 0, 0 into 0 is 0. The second case, we have 1, 1 into 1 is 1. Then we have 2, 2 into 2 is 4, and so on, till 10 into 10 is 100. So here what we need to do is for I in range 11. So basically we are iterating over a list of numbers from 0 to 10. We have to print using the formatter thing that we string formatter operation that we talked about. We just print I into I is equal to I multiplied by I. This should print out the result as shown before above. Okay. Okay. The next question is use for loop to iterate from 0 to 100 and print the sum of all even numbers and sum of all odd numbers separately. So now we need to have two variables, some evens and some odd, so that we keep track of the sum of all the even numbers and sum of all the odd numbers. Okay. Then we put a for loop to iterate over 0 to 100. So range here is 101, so it goes from 0 to 100. Okay. Then we check if the number is even. If the number is even, that means it's divisible by 2. So if I percentage 2, which gives the remainder of division by 2, is 0, then we add the number to the even number sum. Otherwise, we add the number to the odd number sum. Then at the end, we have a print statement using string formatting, which basically prints out the statement sum of all even numbers is dash and sum of all odd numbers is dash. So we now run this. And we see that sum of all even numbers is 2550 and all odd numbers is 2500 from 0 to 100. Okay. In the next question, we are asked to reverse the order of the list given below using a for loop. So we are specifically told to use a for loop here. So we have fruits, which is a list, banana, orange, mango, lemon. We want to print out lemon, mango, orange, banana. Okay. So basically we are creating a new list, which is new fruits. Then we are iterating over backwards on the list. So basically here we are getting the value for the length of the list, which should be 4. Then yeah, length of the list 4, then -1, 3, because the last index will be 3. It will be 0, 1, 2, 3. 0 banana, 1 orange, 2 mango, 3 lemon. So this part is evaluates to 3. Then we iterate till -1. Okay, because then only it will go from 3 to 0. And then we are decreasing it every step. 3, 2, 1, 0. We are decreasing it. That's why we have -1 here. And then in that order, by iterating from backwards on the list, we are appending each item to the list. Okay. We are accessing the item at index I from the list and then appending it to the new list. In the end, we just print the new list. Remember, we talked about reversing a string just using an indexing operation. So this is how it goes. So instead of this whole for loop and everything, we can just write fruits, square brackets, colon, colon, -1. It will basically reverse the list, which should give us lemon, mango, orange, and banana. Okay. The next question is write a function to calculate the area of a circle given its radius. The area of the circle is given as pi into r square. So pi into radius, pi into r square. Okay. We can use 3.14 as the value of pi. Okay. So here what we are doing, we are first defining a function called circle area. In the arguments, we have a radius because the user needs to provide the radius. We need to provide the radius. Then we return 3.14 into radius, basically. Now, if you want to calculate the area of a circle with radius 5, we just call the function circle area, and then we give our argument 5. Okay, which turns out to be 78.5. Declare a function named print list. It takes a list as a parameter and prints out each element of the list. Okay, so we have the function print list. It takes L, which is a list, as an argument for I in L. So for each element in L, print I. So that's basically it. Now we have a test list, fruits, banana, orange, mango, lemon. We have print list fruits, which should print out banana, orange, mango, lemon in separate line, just like this. Okay. Write a function which checks if all the items of the list are of the same data type. Okay. So now we have a function called checklist, which takes an argument L, which is a list. Then first we have a variable called data type where we store the type of the first element of the list. This is for comparison. Okay. Then we have a for loop for items in L. So we are iterating over the list and we are taking one item at a time. If type of item is not equal to data type. So if the type of this item is not equal to the type of the first item, return false. Okay. If it is the case that it is equal to the data type, we do nothing, we just pass. Then we go to the next item. And at the end, if the for loop is executed and all the items are checked and there is nothing wrong with it, no item has a different type, then we return true. Okay. Remember that once you return from a function, you use the keyword return to return something from a function, the function execution stops there. So the first time we encounter this false here, it will stop and nothing else will be executed. Okay. So we have two test cases here. The first one is a list with name, place, animal thing, which all of which are strings. In the second case, we have a list of strings that also contain some numbers. Okay. Now, if we print checklist, in the first case, it should return true. In the second case, it should return false. So that's what we get, true and false. Okay. The last question we have here is write a function which checks if all items are unique in a given list. Okay. We want to see if all the items in a list are unique. So we have a function here called checklist again, which takes L, which is the list, as an argument. Okay, we create another list called uniques to store all the unique values that we encounter. Okay, for each item in list L, if the item is in unique, so if we have seen the item before, return false. Otherwise, unique dot append item. So if we have seen the item before, we know that it's not unique, so we return false. If we have not seen the item before, then we basically update our list of unique items to contain that item also. Okay, we basically extend that list. Then, if the for loop executes for all items and we don't end up here, we never return false. Then at the end, we return true. Okay. Now, again, we have two lists. The first one has all unique items, and the second one has repeated items. So when we run our function for the first list, it should return true, and for the second list, it should return false. Let's see what happens. It returns true and false as expected. Okay. So that's it for the module 2 practice exercises. I hope you have understood it. If you have any doubts, please let me know. You can contact me via email, or you can also drop a question on the comment box, or you can directly mail your doubts to me. Okay. Next, we'll continue off with Numpy. So before that, I'll just recap what all we had learned in NumPy. So basically, NumPy is one of the most important libraries in data science in Python. Many of the other libraries and packages use NumPy as one of their building blocks. Okay, it helps us carry out a lot of calculations and a lot of linear algebra stuff for Python. So basically, we learned how to import NumPy before using it. We need to import every package before using it in a given script or in a given Jupyter notebook. Okay. Then we talked about NumPy arrays, how to create arrays, then how we can create special arrays that contain only zeros or only ones, or there are different other ways to create arrays, such as using the linspace function, how to create an identity array, and how to create random arrays sampled from different distributions, random integer arrays, random real number arrays. Okay. We also talked about some array attributes and methods, such as reshape, minimum, maximum, argmin, argmax, and all. We also talked about the shape of an array. Okay, how we can reshape it to a different shape, how we can make one array into from one-dimensional array to a two-dimensional array and all that. We also talked about data types, and we talked about how we can index an array and select elements from an array using indexing and selection. Okay, we talked a bit about broadcasting. We talked about indexing a two-dimensional array. Okay, we also talked about fancy indexing, which allows us to select entire rows or columns from NumPy arrays in any order whatsoever. Okay, and uh, we talked about how we can use comparison operators to create a Boolean mask and then use that mask on an array to extract array elements that basically return true to the mask that you are applying. So in this case, for example, we want to just extract elements which are greater than 4. So we create a mask array greater than 4, which returns basically Boolean values for each variable, for each number that is there in the array. Then we can use that Boolean mask to basically index elements in the array and call all those elements and show it to us. Okay. So now we'll talk about NumPy operations. Okay. So basically, we have array, which is the main data type of NumPy, and NumPy provides us with excellent tools that can help us carry out any kind of arithmetic operations, both between scalars and arrays, so and also between different arrays. So let's first define an array. So we'll use the arange function to define an array. Sorry, I first need to import NumPy. Okay. Then we basically run this. So we defined an array from 0 to 10, which has the value 0, 1, 2, 3, 4 till 9. Okay. Now let's say we add the array to itself. What basically happens is each of the elements in a given index are added. So basically we put two of these arrays side by side, and based on the index, we just add values. So the 0 will be added to another 0, it will result in a 0. 1 will be added to 1, it will be 2. 2 will be added to 2, it will be 4. So 0, 2, 4, 6, 8, and so on till 18 we should get. Okay. Now if we subtract an array from another array, we basically subtract one element from another using the minus sign here. So it should return an array of zeros because we are subtracting the same array from itself. Right. We can also divide two arrays, which will again do the element-wise division. So we are basically dividing here 0 by 0, 1 by 1, 2 by 2, 3 by 3, and so on. So all of these values will result in a 1. Whereas in this case, since we are dividing 0 by 0, Numpy gives us a warning that it encountered an invalid value while dividing. Okay. And it still works, but it still works and it gives us a number called nan. So nan is basically a representation in Numpy which says it's not a number. Okay. You cannot basically carry out any operations with nan, any arithmetic or numeric operations that you can carry out with in general with numbers. Okay. Okay. Now we are using some scalar to we are doing operation of scalars with arrays. So basically we have written 1 by r. What this does is it basically divides each element in an array. So it divides 1 by each element in an array. So it's basically 1 by 0, 1 by 1, 1 by 2, 1 by 3, and so on. Here again, note in the first case, it's dividing by 0, and it says to us that it wants to us that it encountered a division by 0 while carrying out this operation, but instead of an error it just appends an infinity here. Infinity behaves as infinite, so it's a very large number that again you cannot do many things with. If we do this operator, if we use the exponential operator on the array exponent 3, so array raised to the power 3 basically, it basically raises each element of the array to the power 3. We can also add a given constant to the array, which will basically add a constant to each of the elements of the array. We can also subtract a constant from the array, which will basically subtract a constant from each element of the array. Right. 5 here. Okay. So NumPy comes with many functions which are called universal array functions. So these are essentially mathematical operations that you can perform across different arrays or on arrays. Okay, here are some common ones that we might be using in due time. So np.sqrt array, it basically takes square root of each element of the array. We have the array from 0 to 9. So it takes the square root of 0, 1, 2, 3, and so on till 9. We get a 3 here. Again, we can do exponentiation. So np.exp array will basically raise each element to the power of e. So e to the power 0, e to the power 1, e to the power 2, and so on till e to the power 9. Right. We have np.max array. It's basically the same as array.max that we did earlier. Okay. It basically gives you the maximum number that is present in the array. Then we have np.sign array, which basically gives you the sign of the number that you are inputting, sign of all the elements in the array. It's basically sign of 0, sign of 1, sign of 2, 3, 4, and so on. Okay. np.log array basically gives you the logarithm of each element in the array. So again, here we cannot basically take the logarithm of 0. So Numpy gives us a warning here and it assigns the value minus infinity. Okay. Logarithm is only defined for numbers which are positive and greater than 0. Okay. So that was all for Numpy. Here are some references that you can go to learn more about Numpy. And here also, in between the document, there are a few links here and there. You can check those out. There's an exercise based on Numpy. Okay. So basically, in the first place, you have to import Numpy. Then you are asked to create um, different arrays, and some example output is given below each cell. Okay, so that you can compare your result to it. Then in some of the places, you are given some result. Okay, some array like this, and you are basically asked to write a piece of code that can output the given array. So in this cases, don't write anything here. Okay, in the block that is giving you this result. Okay, otherwise this result will be lost basically right here. Okay, in the block that has uh, all the comments, write your answer here and then run your code. So then check if the array that you're getting here is the same as the array below. We have a few questions of this type. Okay. So here you are given a matrix to work with, and in the below questions, you have to basically select or index the matrix in a way so that you get this matrix, which is this part here from 12 to 25. Right. This, and so on. Okay. So that's it about the exercises. I'll upload these exercises. I'll send you by email. So you can try out these exercises and let me know if you have any doubts regarding these exercises. Okay. So today we'll learn about another Python package, which is called Pandas. So Pandas is basically a Python package that provides us with certain data structures that are designed to like help us work with data more efficiently and more intuitively. Okay. Pandas is mostly used when you are cleaning your data, when you are transforming certain variables, or when you're analyzing your data and you are starting out and you just want to arrange your data, you want to get rid of missing values and filter some rows and calculate some basic descriptive statistics on the data. Okay. So this pandas library is again built upon the NumPy package. Uh, so data that we process using pandas can also be processed using some functions in NumPy. As you will see, we'll be using a lot of these libraries together synergistically to achieve a certain goal. Okay. After this, data that is processed in pandas is uh, often used to feed into statistical analysis using other packages such as SciPy or for plotting using Matplotlib and machine learning using scikit-learn packages. We learn about some of these packages in the later modules. So before we start with this module, make sure that you have installed Pandas in your system. You can do so by running pip install Pandas in your Python console, right? You can also do that here. Basically, inside a Jupyter notebook, you can write exclamation pip install Pandas. So if I run this block of code, it says requirement already satisfied because I've already installed the package Pandas. Okay. The first main data type that we will learn about in Pandas is called a series data type. Okay. A series is basically similar to a Numpy array. Okay. In fact, it is built on top of a Numpy array object. What is different here is that a series can have labels. So, meaning that each value that you put in a series can have certain label attached to it. So instead of the marks that we had here in the module 2 here, instead of having it as a dictionary, we can have it as a pandas series where the names are all the labels and these are the values. We have a series of marks and the labels are names of people. Okay, so let's look at it in more detail. So first we'll import both NumPy and pandas because we'll be using both. So we'll first learn how to create a series. So you can basically create a series using a list, an NumPy array, or a dictionary. So here we have a list called labels, which is ABC, which are basically labels for the data that we are trying to make. Then we have a list, my list, which is 10, 20, 30. We have a NumPy array, which is again the same. And then we have a dictionary, is basically this labels A mapped onto the numbers A10, B20, C30. Okay, we first define all this. Then what we can do is we can write pd.series. So basically PD is the pandas package and series is a function inside it. Function or a method inside it. Okay. So pandas series data is equal to my list. So this basically creates a series. And we see that it's of the data type integer and these are the row labels 0, 1, 2. Since we didn't provide any labels, it basically assigned a numerical label 0, 1, 2, 10, 20, 30. Now, if what if we provide a list of labels? So basically, here we have two keywords: data is my list and index is labels. Okay, so basically, if we run this code, we see now instead of 0, 1, 2 here, we have ABC as the label for the points that we have 10, 20, and 30. We can run this code without using the data equals and index equals. So basically, the first argument you put here should be a list or a triple of that kind, and the second one should be labels for that list. If we run this, we get the same answer. We get the same result, which is ABC and the values 10, 20, and 30. Okay. We can also use NumPy arrays. So like before, we just put an array here. In this case, we are not giving it labels, so it's 0 and 2. Again, we can use pd.series array and then give it labels, which is a list, which will again assign labels to these values, A10, B20, C30. Okay. We can directly invoke pandas.series onto a dictionary where the labels are mapped onto the values. So remember the dictionary that we created, D, A is 10, B is 20, C is 30. We can just type pandas.series D and it will give us the series 10, 20, 30 and the labels are A, B, C. Okay. So pandas data series can hold a variety of object types. Okay. We can create a series of characters. We can create a series of numbers and we can create a series of lists and whatnot. Okay. We can even create series that contains functions. So basically, we just write names of the functions without giving arguments to them into a list, and then call pd.series to create a Pandas series on that. So now we can store like each of these rows here stores the function. The first one is sum, the second one is print, the third one is len, and so on. We see that in most cases the data type here is an object. So a data type object can be used to represent basically anything in a Pandas series. Okay. So now we'll look at how to, now that we have created some series, we look at how we can get some data out of those series. Okay. So here we are basically making series one, which is a series which has the values 1, 2, 3, 4. And the index we have US, Germany, names of countries basically. So we create this and then we print this. It's the labels are names of countries and the data that we have here are numbers 1, 2, 3, 4. Okay. Then we create another pandas series with some other numbers and some other names of countries. Okay. So now we have again US, Germany, Italy, Japan. So note that the first two here are same. The first, third one is different, and the last one is also same as previous. Okay. So what we can do here is we call series one, and then in square brackets we write the label that we want the value for. So basically, we want to know what is the value of USA in this series. Okay, it should return 1. 8. Now, if we add two series, like we had added Numpy arrays, here what we get is for Germany we get 4, for Italy we get 9, for Japan and USA we get 8 and 2. For Italy and USSR we get 9 because they are not present in both the series. So here the value of USSR is 3, but here the value of USSR is not assigned. So Pandas assumes it to be nan. Then when you add nan to another number, you get nan. Basically, that's why both of these are nan. And the rest of the values, USA, which is 2, which is basically 1 plus 1 here. Germany should be 2 plus 2, 4, and Japan should be 4 plus 4, 8. So we have those 2, 4, 8. Right. So that's some basic stuff regarding series. We'll look into it more deeply as we go further. Now we'll look at something called data frames. So data frames are basically the main kinds of main type of data structure that you will be using in Pandas. Okay, data frames are basically inspired from the R programming language. Sorry. You can think of a data frame as a mm, bunch of series objects put together to share the same index. So it's basically data arranged in table format where each series serves as a column and then we have an index for each row. Okay. So now as before we'll use numpy.random to we basically import random so that we can create a numpy array using these random numbers. So basically what we did here was pandas.data frame. The first here thing that we have is the data. So basically we have rand in 5 comma 4, which gives us an array of shape 5 cross 4. So it has 5 rows and 4 columns. Okay. Then we have index A, B, C, D, E. Dot split is basically we are splitting this based on the spaces that it has. So if I just write A, B, C, D, E, it gives me A, B, C, D, E. But if I write the same thing and put a dot split here, which is a string method in Python, it gives me a list separate so that like each element is separated by a space. Now, if you were to remove the space here, then it will print CD as a single unit because there is no space in between. So the split function basically splits a string based on whatever separation character that you provide. So here, since we are not providing anything, it separates based on the space. That is the default. Okay. So here what we are doing, index is ABCDE split. So index is basically ABCDE and columns are WXYZ dot split. So columns are basically list W, X, Y, and Z. Okay. Now if we run this code, we see that we have a 5 by 4 data frame where the index or the row names are A, B, C, D, E, and the column names are W, X, Y, Z. That's how you create a data frame. Okay. You can also create a data frame using dictionary and all that we had seen before for series. You can use the same logic to create a data frame using dictionaries. In this case, you'll have a lot more things defined. So basically, data frame, and here we should have a dictionary. A One second. Okay. So here we need to pass an index is equal to sorry. So basically here we have the index is equal to A. Index we can write as X. Uh, So this index is the row name here. And then for each of the column, we have a dictionary. For column A, the value is 10. For column B, it's 20. For column C, it's 30. Okay. You can expand on it. Fine. Basically, column A, we are giving the list of values. Column B, we are giving the list of values. Column C, we are giving the list of values. Since we have two values in each of the columns, we have two rows of data. And thus, in the index, we need to provide two row names, which is X and Y. So now it's giving X, Y. And the column names, we have A, B, C. And we have all the values there. Okay. Is that clear? Great. Uh, So now that we know how to create data frame, let us look at various methods that we can use to get data from a data frame. Okay. So basically, we have the data frame that we created above, DF, which 5 cross 4 data frame, which has 5 rows and 4 columns. We can basically, in a square bracket, we put a list, the list of columns that we want. So we want only the W and the Z column values. We can use this and we can get the values just for the columns W and Z. We can also use df.w, which will give us the values that are present only in the series W or only in the column W to get like values from columns. So you can either pass the list of column name or you can use df.column name. to get the value. Okay. Columns of a data frame are basically series. So if we find the type of TFW, which is basically one column W from the data frame, the type is series. Now, if we were to write type DF for the whole data frame, the type is data frame. Okay. We can create new columns that are based on some operations in existing columns. So basically, now we want to create a new column, which is the summation of the columns W and Y. So we can do that by assigning df square brackets new. So we are basically creating a new uh, column and giving it the name new is equal to data frame W, this series, plus data frame Y, this series. So it will basically add the values from these two series objects and then save those values in the data frame as new, as the new column called new. Basically, if we run this, we see we have a new column here. Is basically summation of W and Y. 2.7 plus 0.9 is approximately 3.6. This plus this is this, and so on. Okay. We can drop columns using the df.drop function. So basically, we have a data frame df. We write df.drop and we write the name of the column, or we give it a list of columns, a list of names of columns. And here we are specifying axis equal to 1 so that it drops a column matching this name. If we specify axis equal to 0 and we give a name here, it will drop the row, not the column. Okay, so basically we do this. We have basically dropped the new column that we had here. And now if we do df.drop a axis equals 0, so it's basically looking at the rows now. We'll drop the row that is titled A. Yeah. Before that, you notice something that the new column that we had earlier dropped is still there in the data frame. So if we check the data frame again, alas, both the new and the A row and the new column, both of which that we dropped earlier, are still there in the data frame. So what just happened? So basically, if you run df dot some function like drop, it automatically does not drop anything. It just returns you a view of the data frame where this variable is dropped. Unless you tell it to drop something explicitly from a data frame, it will not drop it. So how do we do that? So basically now we have df.drop. We are dropping the new column, which is axis 1, which is basically columns. And we write in is equal to true. So basically drop the column in the data frame. So now if we run this, now note that this is not giving us any returning any view. This has basically happened inside the data frame. And now if we run the data frame, we see that the new column has been dropped. Okay. As mentioned, you can also drop rows this way. So here we are dropping the E row using axis equal to 0. Okay. For selecting rows, what we do is we use df.loc lock. Okay, df.lock, then there's a square bracket. Inside the square bracket, we give it the name of the row that we want. So we just want to select the first row, which is the A row. We write df.lock square bracket A. So it gives us the row A. It gives it as a series, and all the values for W, X, Y, Z is given here. We can also, instead of if we give lock, we have to give the name of the label of the row. So remember, each of our rows has a label A, B, C, D, E. We give the name of the label for the row. However, if we don't want the label or if we don't know the label and we just want to know what is there in the second row or the third row or the first row. We do df.ilog and we give it a number. The number is the index. So df.ilog2 should basically give us values which are there in the third row, 0, 1, 2. So it will give us values from C. It should start with minus 2.018 and end with minus 0.58. Let's run this. See, minus 2.018 and ends with minus 0.589. Okay. So again, if we want to select a subset of rows and columns, we can use the df.log function where in the first argument here inside the square bracket, we pass the name of a row and we pass the name of a column, comma, and we write the name of a column. So this will give us value of B and Y where they intersect. So this value, right? We can do the same to get sections of the data frame. So now we are selecting two rows. We are using a list here instead of just a single value. We are selecting two rows A and B, and we are selecting two columns, comma, Y and W. So basically, if we run this, we get a data frame part, which is the rows A, B, and the columns W and Y. Okay. So similar to what we did for Numpy array, we can also use a mask and we can also use the square bracket notation to select uh, data from the data frame that satisfies certain conditions. So now let's say we have the data frame here. We have positive and negative values. We write df greater than 0. Like we had array greater than 0, array greater than 4 and all that. We write df greater than 0. It basically gives us a Boolean mask. So this is called a Boolean mask. It has the same structure as the data frame and it has values true and false. True is wherever this equation is satisfied and false is wherever this equation is not satisfied. So for example, here it's false because here this value here, which is B and X, so value from B row and X column is negative. So this is not satisfied. That's why we get a false here. And here, since the value is satisfied, we get a true here. Here again, the value is satisfied, we get a true here, and so on. Okay, so we have a mask now. Now what we do, df square bracket, and we write the mask inside it. So this will basically select all the places where this condition evaluates to true. Okay, so wherever in this matrix the value is true, it will just give us those values. And the other values, it will give us none. Okay, we can do some complex operations using this in pandas. So for example, here we have the data frame inside the square bracket. We are selecting wherever the value of this column W is greater than 0. So this column W that we have, wherever the value is greater than 0, so it's just less than 0 in C, rest of the values should be selected. So we just drop the row C because the value of W in that row was less than 0. Note that if you do this, it still returns you the whole of the data frame and not just the column W that we are putting here. It just returns you all the rows where this column, where this condition evaluates to true. Okay. Now, what if we just wanted one column instead of the whole thing? So now again, we put the condition here, df square bracket dfw is greater than 0. That's the condition here that we had earlier. Then after the condition is executed, we just select the column y. We are basically indexing again using the column y. So now it should give us only the column Y and the values A, B, D, E because C is less than 0. The W value of C is less than 0. So this is not satisfied this condition. Okay, is this clear? Great. We can select multiple columns or rows instead of just one here. So inside the square bracket, we again put a list here and we write Y and X. So we just get Y and X for A, B, D, E, not for C, because the value of because this is returned as false in C. The C W value of C is less than 0, not greater than 0. Okay. If you have two conditions that we want to check for, so let's say we again have the data frame, the same data frame. We want to only get the elements where the value of W is greater than 0 and the value of Y is greater than 1. Okay. So now we can put two conditions inside the square bracket. So first, what we need to do is we need to enclose each condition in a parenthesis. So basically, the first condition here checks if the value of W is greater than 0 in the data frame. Then the second condition here checks if the value of Y is greater than 1. And we are using an AND operator to merge these two. So basically, if both the conditions evaluate to true, then only the whole thing evaluates to true, and then only we get that row or column or part of the data frame. So basically, this both the conditions are satisfied only in the row E, where the value of W is greater than 0 and the value of Y is greater than 1. In rest of the cases, it is not satisfied. Both the conditions are not satisfied. Now, if we were to use the same thing, and instead of the AND, we were to give it a pipe, which basically represents an OR, this would give us all the rows where either of the conditions are true, either or both. Wherever this is executed as true, it will give us, or wherever this is executed as true, it will give us. So again, this will basically give us A, B, D, E, because in the case of C here, the value of W is less than 0, and for Y, only we get the row E. So basically, we get A, B, D, E. A, B, D, and E from this equation, and only E from this equation. Okay. Next, we will discuss some more details about indexing, such as resetting the index or setting it to something else. We'll also talk about having multiple indices in a data frame and what it means basically. Sorry. So let's say we have the data frame that we had earlier. We write a function called uh, df dot, we use a function called df dot reset underscore index. So it basically resets the index to default of 0, 1, 2, 3, 4. And the old index that was there, the old row names A, B, C, D, E, is moved to another column titled index. Okay. Again, note that the data frame is not modified. Here, if we want to modify the data frame, we need to use here inside this in place is equal to true. Then only it will basically do carry out the operation on the data frame. Okay. Let's say we have a new index, which is this list. So we are basically splitting it by spaces. We have 5 values, CA, NY, WY, OR, and CO. So if we print out new index, it means CA, NY, WY, OR, CO, 5 values. So we have in the data frame, we want to add a column called states, which have all these values. So states is given as the list here. We just added that. Now we look at the data frame. We have the values that we had before and we have the states. Now we write df dot set index and we give it a name of the column. And we give the name of the column that we want to set as the index. So basically, the states column that we have that recently that we have added, we want to set this as the index instead of ABCDE. So if I run this code, we see that states here becomes the index, and we have W, X, Y, Z. The previous index that were ABCDE have been dropped from the data frame. But this is still not reflected here because we are not using the in place argument here in the set index function that we are using. So what we'll do now, we'll set index as states and we'll write in place is true. And then we see the data frame is this. So the previous index uh, column, which consisted of A, B, C, D, E, has been dropped. Now we just have this old one, this new one. Sorry. Okay. Great. Then we'll move into multi-index uh, and index hierarchy. Okay. So first we'll create a example of what a multi-index data frame would look like. So basically we have um, some list called outside, which has the values from G1, G2. We have a list called inside, which has 1, 2, 3, 1, 2, 3. And we have a basically in here, we are creating another list, which is a zip of both of these. So we'll take a look at that and run it step by step. So here I'm defining two lists. Okay. Here I'm basically defining another thing, another list, which is higher index. So it's basically zip function here. What it does is basically it glues together corresponding objects from different lists. Okay, so we have a zip object. Uh, we can't basically access values like this, but if we iterate over it, we can get the values. So in each iteration, it basically returns a tuple, which is basically pairwise elements from these two lists. So outside first element is G1, here first element is 1. So we get G1 1, then we get G1 2, G1 3, and so on. G2 1, G2 2, G2 3. Okay. So we are basically defining that and we are printing it out. The whole thing we are then converting into a list. The whole thing that is present in the zip, we are converting it to a list. So now we have a list of tuples. Okay. Now what we need to run is, so pandas pd.multiindex.from tuples and we give it the list of tuples. Okay. So we have defined this as an index. So this is the index here. There is an index object in pandas, which is basically a list of tuples. Okay. So now what we are doing here is we are again using the random uh, function that we used before. So if we run this, it gives us basically a list of random, sorry, a two-dimensional list of random values, 6 rows and 2 columns. Okay. Then here, note and the indices, we have 6 rows. Okay, so the number of rows should match. So we are creating a data frame with these random values. Then we are giving it the higher index that we created here. And we are giving it the column names, which is A and B. Okay, so these two columns need to have some names. No? So the first column is named A and the second column is named B. And when we create that, we see that we get something like this. So basically, here we have two indices. The G1, G2 here is the first index, and the 1, 2, 3, 1, 2, 3 here is the second index. So these can basically uh, be anything. So for example, if you're working in biology, if you're working in gene expression or something, G1, G2, G3 can be different genes, and 1, 2, 3 can be the values that you get from different experiments. So for example, uh, A is when you added some reagent A into the mixture and see what is the expression of gene A. You run first trial, second trial, third trial. You get three values for G1 for A. Again, B is another experiment where you are adding another certain different reagent and you are repeating the experiment three times. For gene 1, you are getting values 0.4, 1.02, 1.86. Then you repeat the whole set of experiments for G2. You get three values for A, three values for B. That's how it's structured here. So this basically lets us structure our data properly, like the way it should be, right? When we do some complicated experiment or something, right? So now that we know how to create something with a multi-index, how can we access things in there? Okay. So basically, if like before we just do df dot log g1, we basically want all the g1 values. We still get a data frame. We don't get a single value or something. Okay. So what we do here, we can chain a lock with another lock. So basically here we are getting the value from the first index, which is G1 or G2, then lock, and we are providing a value of the second index that we want. So we want the data for gene 1 from the first experiment. Okay. So the line here gives us basically all gene 1 data from all the experiments and all the treatments. Here, it gives us value from gene 1 for experiment 1. So if we run this code, we just get the first two values, 0.4 and minus 0.47. Okay. So this function df.index.names is basically a name of the indexes. So like each column here has a name. In this data frame, each of the columns has a name. Like that, for each index, we can also add a name. So now since it is empty, it's returning as none basically, because both the indices don't have a name. So now if we want to assign some names to the indexes, we write df.index.names equal to, and then we give a list. Because we have two indexes, we give a list of two names. If we had one index, we could have just given a single name. So now we are writing it group and number. Now if we check the data frame, we see that the first index is named group, the second one is named number. Instead of group and num, what we can do here is, as an example, explained before about the experiment in genes, we can write gene and experiment. So there we get what gene is it and which experiment was carried out. And on the y-axis, like on the horizontal column things, we have the different treatments, A, B, and all. Okay. So this is also another way to select data from indexes, multi-index data frame. So basically we write df.access, okay, and then we give it the index. So basically we just here want everything that's there in G1 index. So we give df.access, then in uh, parenthesis we write G1. So we get just the G1 data. Now, if you wanted experiment 1 data for gene 1, we write df.access and then we write gene 1, comma 1 as a tuple or a list. This will give us the value for first experiment. Okay. This we need to change. Huh. So now basically df.access one level equal to experiment. So basically we are looking at the level second level. So there are two levels of indexing. No, the first one here is G1, G2. The second one is 1, 2, 3. This experiment. First one is G, and second one is experiment. The first level is the second level. So here what we are doing, we are giving it a value of the label, and then we are telling it which label to look at. So we want wherever the experiment is one, we want those values only. So here we just get for gene 1 and gene 2 in experiment 1. Experiment 1. For gene 2 experiment 1, minus 1.13 and 0.6. Those are the values that we get here. Okay. Is that clear? Great. So now uh, we'll talk about how do we input and output data using Pandas. Okay. So Pandas has a variety of methods called pd.read underscore something. Okay. So these methods can be used to read different kinds of data such as CSV files, which are comma separated files, or we can also read Excel files, or we can read other tabular data that you might have stored or you might be getting as outputs from some experiments or something, uh, some machines that you might be running. Okay. So what we do here is df1 is equal to pd.read_csv example. So I need to tell you basically example is a file here that I have saved. It's basically a file which is comma separated. So I have first the headers A, B, which are the column names, and then I have two values each for each column separated by a comma. And then for each row, it's basically in one line. So this here is the value for first row, this here is the value for second row, third row, and so on. Okay. Now if I do this and show you, it reads the value from the file. We have the example file here. We have the columns A and B. It reads the column names A and B correctly. And then it reads the file values, basically 0.3, 1.6, and so on. These values it reads. Okay. Huh. That's how you can read CSV files. So Pandas has a function called pd.read_csv, where first you provide as a argument the uh, location of the file. So since both the files are present in the same folder, I just need to write the name of the other file. Okay, along with some extension. So note that this example file does not have any extension. So we are not using the extension here, but later we'll be using. If you want to store something as a some data frame to somewhere, okay. So now let's say I want to do df.toCSV. So it will basically store the data frame to a comma separated value for CSV file. Okay. So df.toCSV example.txt example.csv, let's say, and I write index equal to false. So index equal to false will basically not include the index in the file. If I write index equal to true, it will include the index in the file. So note that, yeah, there's no file here. If I run this piece of code, we see a new file called example.csv. If we open that, it has the values that we provided. Okay, the data frame here. Right. So if I were to do index equal to true and then run this, what would happen is along with the values for A and B, we'll store the index values here. The index, remember, for the data frame was gene and experiment, right? So we'll store the index values. Now, if I remove the index is equal to 2 as index equal to false, we'll just store these A and B values and not the indexes. Okay, is this clear? Great. Pandas can also be used to read and write Excel files. Okay, so this method is very basic. It can be used to read Excel file, but keep in mind that it will only import the data that you have. It will not import any formulas or images or charts that you might have in an Excel file. Okay. Or Excel allows you to write some code in their Excel language, which is called macros or something. Those things also won't be imported into the imported while you're using Excel. Okay. So basically, I have the function pd.readExcel, which reads an Excel file. I have to give it the name of the Excel file that exists along with the full uh, file extension. And then I give it the name of the sheet that I wanted to read. So Excel files have a lot of sheets sometimes. So for example, if I see the file here, okay, just a second. We'll open this in File Explorer. Just a second. Yeah, I'll stop sharing and share it again. Okay, is the Excel sheet visible to everyone? Okay, great. Someone said yes. Okay. The Excel sheet is visible. So here you have a sheet called sheet one. You can have multiple sheets in Excel. And here we have the file. Here we have the table in Excel that we want to import. Okay. So now what we'll do is we'll do pd.readExcel. We'll give it the name of the file. We'll give it the name of the sheet, and then we'll just execute it. So it reads basically. Note that since it does not read the numbers group, read these columns group and number as indexes, okay, it basically does not, since the values were not uh, there. Basically, if you see here, the second and the third, these are basically merged in Excel to give G1, but the value of the second and third in Excel are still not G1. So that's why we are getting here NaN values. Okay. So if I go to Excel and change that, if I, so these complex formatting things that are there in Excel, these things won't basically show up properly when you're reading a file. So make sure that the file that you want to read or the file that you have is properly formatted and there is no like other macros or charts or images in that file. Okay. So basically now I have corrected this Excel sheet. Now if I read it again, it should give me all the proper values G1, 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 G2, G2, G2. Okay. To save files to Excel, what we need to do is df.toExcel. So basically we are providing the data frame that we had df. Then dot to underscore Excel is basically the function that writes to Excel file. We are giving it a name and then we are telling it which sheet to write to. Okay. So this is done. Now we have the Excel sample file here, the sheet here. It routed back again because the data frame that we have still has that index file. So these rows are basically empty. when it's writing to Panda, these rows are basically empty. So that's why this is creating a file like this, where it's merging these things. But when it's reading again, it's not picking it up. So always be careful when you're saving something to Excel or some other file format. Make sure that you reset your index and then save your file. Okay. So we have a little bit more to cover, which is how to deal with missing data. So basically the NaN values that we had before in Numpy and now again in Pandas, the NaN values, what do we do with it? Okay. That's something that we have to know. Then about certain operations that we can carry out to get certain outputs from the data frames that we have. How we can select some data, apply some functions, and remove columns and do other certain things. And we learn about something called group by, which is a very important method in Pandas that helps you to basically aggregate a lot of data and then carry out a lot of functions on it. Okay. And we talk about a lot of different aggregate methods, and then we talk about how we can merge or concatenate and uh, join basically data frames. Okay. So that's all there is for pandas. But uh, so these parts, it might be slightly overkill if I do everything right now. So for today, we'll stop here. Tomorrow, otherwise, we can just look at how to deal with missing data and we'll stop there. Okay. From operations and the rest of the merging, concatenating, and all the other things, we'll learn about it tomorrow. Okay. And after that, I'll give you the assignment. So first, we'll take a look at this. So, yeah. So let's say we have a data frame here that we create. It's basically ABC are the three columns. This is a dictionary. I'm using a dictionary to create a data frame. ABC are the three columns, and in each column, I have different values in the rows, three different values in the rows. So basically, A has the values 1, 2, NaN, B has the value 5, NaN, NaN, and C has the value 1, 2, 3. Okay, so this is how the data frame looks. What we can do is we can write df.drop NA, which will basically drop the rows that have uh, NA values. So let's say you do an experiment and you get a huge data sheet. Let's say you run like some uh, complicated molecular experiment, or you run some simulation or something and it fails sometimes, or your molecular experiment has some contamination or something like that, and some of your samples don't work. So those values you have to remove. So those values you put as NA or not found or something like that. So let's say this is a matrix containing that. So df.drop NA basically drops all the rows that have NA values. Okay. So let's say for some sample, let's say we have sample number 0 and 2. For some sample number, we have a lot of NA values. So instead of analyzing using that sample, it might just be better to drop that sample off. So that is something you can do using df.drop NA. Okay. If you do df.drop NA axis equal to 1, so you basically drop columns instead of rows. So now note that every column that has a NA value has been dropped. You just have one column which has no NA values. Depending on how much NA values you have, and if most of them are in a single or a few columns, or most of them are in a few rows or one row, you can use the drop NA function based on that and write axis equal to 0 to drop rows and axis equal to 1 to drop columns. Okay. Then we write something called drop NA thresh equal to 2. So thresh is basically a threshold. It basically tells pandas that drop a row only if it has two or more NA. So in this case, the first row, which has only one NA, has not been dropped. Now, if we run the same thing with x is equal to 1, what we'll get is we'll get A and C, and the B column has been dropped because the B column had two NA values. Okay, we can do df dot fill NA, and the value that we provide here will be the value that will be used in place of NA. Okay, so basically, instead of all the NAs that we had before, note that none of these operations have been changing the data frame because I have not been using in place equal to true anywhere. Because I just want to keep the data frame as this and show you each operation separately. But when you are carrying out these operations on your data frame in real time, do note that you have to use this keyword in place equal to true, this argument. Okay. Basically, we have the data frame here. I write df.fillNA and I give it a some value. So basically, instead of all the NAs, it will fill this value. If I give the value as, let's say, 2 or something, all of it will be filled with 2, all the NAs. Okay. So again, we have the data frame, nothing has changed. What we do here is we select data frame column A. We select the first column. Okay. And then we write dot fill NA. So in the first column, we are filling the NA value, and the value we want to fill it with is value of dfa dot mean. So this thing basically, dfa is basically selecting the first column. Dot mean is basically the mean of that column. So if we run this, it gives us 1.5. Note that this method or this mean function that we are using here basically ignores the NAs that are there in the row. If we run the same thing for P here, we get the mean value of 2, 1 plus 3 plus 2 by 3. Okay, if we run it for B, we get the mean value of 5 because it's 5 divided by 1. The rest of the values are not taken into account. Okay, so basically we are selecting this row and we are filling the NAs with the mean of that row. Okay, so sometimes what you want is like, let's say you carry out some experiments or basically these 0, 1, 2 are basically replicates of something or some other thing, and certain values you don't have. So in that case, what you can do is instead of the NaN values, or instead of putting some random values, or instead of putting some, let's say, zero value or something, it's better if you put a mean value for the whole row based on other values that are there in the row. So that is basically what we are doing here. Okay. So basically we are getting the first row. The zero thing is 1, the second one is 2. The third one, which was NaN before, is now 1.5, which is the mean of 1 and 2. Okay. So that's it about uh, dealing with missing data in Pandas. Next class tomorrow, we'll look at operations and the rest of the things to do with Pandas, and I'll give you some exercise. Then we'll move on to the next module. Okay. So thank you for coming today. Uh, so we'll meet again tomorrow at the same time, and we'll continue with this. Okay. The assignment for module 3 will be given to you by your email. Do solve that and do let me know if you are facing any issues. Okay. Thanks and good night.